Dawn fractures against a wall of iron teeth. The machine does not wake. It is already awake, breathing, vibrating, waiting with a patience measured not in minutes, but in pressure. Steam coils upward from its joints, drifting into the pale morning air like a warning no one can translate. Beneath it, the quarry floor lies split open, a wound carved into the earth, its edges raw and jagged, its depths shadowed and unknowable. Then, without ceremony, the first stone is fed. It disappears instantly. A slab weighing more than a house vanishes between steel jaws wider than a railway carriage. There is no struggle, no resistance, only a single concussive crack that rolls across the valley like distant artillery. The ground shudders, dust erupts, men flinch, but only for a fraction of a second. The machine demands rhythm. Hesitation is dangerous. 14,000 tons of engineered force compress into motion. Gears taller than men begin their slow rotation, teeth interlocking with mechanical certainty. Pistons drive forward, each stroke calculated, each impact carrying the weight of entire hillsides. Stone after stone is consumed, broken, reduced to fragments that pour out like controlled avalanches. What took geological epochs to form is undone in seconds, and still it is not enough. The machine does not pause. It cannot. Its hunger is calibrated to supply railroads, cities, empires. Every second it stands idle, men lose wages, contracts collapse, progress stalls. So it is pushed, harder, faster, deeper into the earth. Operators watch gauges climb, bearings heat, metal strains. Somewhere inside the crushing chamber, something shifts. A sound, too sharp, too irregular, cuts through the rhythm. But the next stone is already falling. The stone does not resist because it cannot. It fractures along invisible lines, weaknesses written into it long before the first human hand ever touched it. Under pressure, even mountains reveal their faults. The machine understands this. It does not invent force. It concentrates it, focuses it, weaponizes it against time itself. Each rotation of its gears is a negotiation with geology. Each impact a decision to accelerate what nature once intended to unfold over millennia. And yet, there is a contradiction at the heart of it. The same act that destroys the earth is the act that builds the world. Railways do not rise from untouched hills. Cities do not emerge from unbroken stone. Every foundation, every bridge span, at every mile of track begins here, in violence so controlled it becomes invisible. The crusher does not simply break rock. It transforms it into possibility. Gravel becomes ballast. Crushed stone becomes roadbed. Dust becomes cement. From fragmentation comes structure. But the cost is never confined to the material. To sustain this transformation, the machine must operate without pause. It must be fed continuously, its appetite matched only by the scale of the ambitions it serves. Industrial expansion does not tolerate interruption. Contracts are written in tonnage. Deadlines are measured in shipments. The machine is not an isolated invention. It is a node in a vast, interconnected system that stretches from quarry floor to distant cities, from laborers' hands to the ledgers of financiers who will never hear the sound it makes. So it runs, and daylight fades. Lamps replace the sun. The rhythm continues. Crush, release, crush again, until the distinction between day and night dissolves entirely. Men adapt to the cadence. They learn to read the machine not with instruments, but with instinct. A subtle change in vibration, a delay in the cycle, a note in the grinding that does not belong. Because beneath the promise of progress lies a quieter truth. The machine cannot distinguish between what must be broken and what should remain intact. It will take whatever it is given, and it will demand more. The hills were not always valuable. For centuries they stood as obstacles, unmoving, unyielding, indifferent to the ambitions of those who passed them. Roads curved around them, rivers diverted. Settlements grew where the land permitted, not where it resisted. Stone was taken in fragments, chipped away by hand, hauled by animal, measured in blocks small enough for a man to lift and shape. Scale was limited not by imagination, but by muscle. Then the demands changed. The 19th century did not ask the land for permission. It issued requirements. Railways began to carve straight lines across continents, indifferent to terrain. Steel tracks required stable foundations, miles upon miles of crushed stone to absorb vibration, distribute weight, and hold alignment under the strain of locomotives that grew heavier with each passing decade. A single mile of track could consume thousands of tons of aggregate. A network spanning nations demanded numbers that dwarfed anything previously imagined. Cities followed the same logic. As populations concentrated and skylines rose, and the need for reliable building material accelerated beyond traditional supply. Roads expanded, first with cobblestone, then with layered systems of compacted gravel and macadam. Bridges extended across rivers once considered impassable. Ports deepened, canals widened. Everywhere, the same requirement emerged: more stone, broken smaller, produced faster. Manual labor could not keep pace. Quarries expanded, their edges cut deeper into the earth, their operations growing more organized, more mechanized. Early crushing methods, simple hammers, rudimentary stamp mills, proved insufficient. They fractured stone unevenly, inefficiently, unpredictably. Output lagged behind demand. The bottleneck was no longer the extraction of raw rock, but its transformation into usable material. Industry responded in the only way it knew how. It scaled. And steam power, already driving locomotives and factories, was redirected toward the problem of fragmentation. Engineers began to experiment with machines that could replicate and exceed the force of countless blows, delivering consistent pressure with mechanical precision. The first crushers were crude, limited in capacity, prone to failure, but they revealed something critical. Stone could be processed not as a craft, but as a system. Production could be continuous. By the turn of the century, quarries were no longer isolated sites of extraction. They became integrated operations, linked to rail lines, synchronized with construction schedules, calibrated to deliver exact volumes of material on demand. Stone was no longer merely gathered. It was manufactured, and with that shift came a new expectation. If the world required millions of tons, then the machine must produce millions of tons. If the terrain resisted, the machine must overcome it. If time constrained progress, the machine must compress it. The hills, once obstacles, were redefined as reserves, vast, silent inventories waiting to be reduced, measured, and moved. Their value was no longer in their permanence, but in their potential to be dismantled. All that remained was to build a machine capable of matching that ambition. It did not begin as a single machine. It began as a series of failures. Early designs fractured under their own intent. Iron frames warped, bearings seized, jaws misaligned under uneven loads, shattering themselves instead of the stone they were meant to break. Engineers recorded each breakdown with clinical precision: cracked housings, stripped gear teeth, stress fractures radiating from bolt points where force had nowhere left to go. The problem was not simply strength, it was distribution. Force, when concentrated without control, destroys the machine as surely as it destroys the material. So they studied the stone, not as obstacle, but as system. They mapped how it failed, how pressure moved through it, how fractures propagated, how resistance shifted under compression. Granite behaved differently than limestone. Basalt resisted longer, then gave way violently. Each demanded a different approach. The solution would not be brute force alone. It would be controlled inevitability. From this understanding, the design evolved. The crushing chamber was angled, not flat, forcing stone downward into narrowing space where pressure increased with each movement. Jaws were shaped to grip rather than strike, converting impact into sustained compression. Flywheels were introduced to store rotational energy, smoothing the violent fluctuations of load into a steady, predictable cycle. Motion became continuous, stress became managed, and then scale was introduced. Frames grew from forged sections into cast structures weighing hundreds of tons. Support foundations were sunk deep into bedrock, anchoring the machine not just to the quarry, but to the earth itself. Power systems expanded, first steam, then compounded through massive pistons and drive shafts capable of translating heat into relentless mechanical motion. Every component was oversized, not for excess, but for survival. The final design did not resemble a tool, it resembled infrastructure. 14,000 tons of interdependent systems, assembled piece by piece, each element calculated to endure forces that would obliterate lesser machines. Gears the size of small buildings meshed with tolerances measured in fractions. Shafts rotated under loads that bent steel imperceptibly with each cycle. The jaws, hardened, replaceable, precisely aligned, opened and closed with a rhythm that could not be hurried, only sustained. It was not fast. It was unstoppable. Once engaged, the machine did not surge. It settled into motion, a slow, deliberate cadence that converted raw mass into output with mechanical certainty. Stone entered. Stone exited, reduced, sorted, measured. The process did not depend on individual effort. It depended on continuity. But continuity required something else. Precision. Every tolerance mattered. Every alignment had limits. The difference between controlled force and catastrophic failure could be measured in millimeters, in degrees of heat, in variations of load that no human eye could see, only detect after it was too late. The larger the machine became, the narrower its margin for error. And yet, the demands placed upon it did not shrink. They grew. Contracts expanded, rail lines extended farther, cities demanded more. The machine, already at the edge of what engineering could sustain, was pushed beyond its intended equilibrium. Adjustments were made, pressures increased, cycles tightened, throughput maximized. Each improvement delivered results. Each also introduced strain, because the machine had been built to endure immense force, not infinite force, and somewhere within its vast structure, the first signs of imbalance had already begun. That inside the machine, there is no silence. Even at rest, it carries tension, a residual hum embedded in its structure, as if the metal itself remembers motion. When engaged, that memory becomes reality. Every component participates. Nothing remains still. Power enters as heat. In the boiler house, coal is reduced to energy through controlled combustion, generating steam at pressures that would rupture an unreinforced vessel. Gauges tremble as needles climb. Valves regulate flow with exacting precision, releasing force into pistons that convert expansion into movement. Each stroke drives a system of rods and shafts, transferring energy across distances measured not in meters, but in mass. The machine does not rely on a single motion. It relies on coordination. At its core, the primary drive shaft rotates with deliberate weight, all supported by bearings engineered to withstand continuous load without deformation. These bearings are not passive components, they are active points of survival, lubricated constantly, monitored for heat, adjusted to maintain alignment under stress. A failure here does not slow the machine, it ends it. From the shaft, motion is distributed outward. Flywheels absorb fluctuations, storing rotational energy that smooths the crushing cycle. Their mass, measured in tens of tons, ensures that each movement of the jaws is not a discrete action, but part of an unbroken sequence. Energy is never wasted. It is transferred, conserved, redirected. The crushing chamber is where that energy is resolved. Two jaws, one fixed, one mobile, converge with controlled inevitability. The angle between them narrows as stone descends, in increasing pressure without increasing speed. This is not impact, it is compression sustained beyond the structural limits of the material. Stone fractures not because it is struck, but because it can no longer exist in its current form. Fragments fall through graded openings, sorted by size, directed into conveyors that carry them away for further processing or immediate use. The system is closed, efficient, continuous. Every output is measured, every deviation is noted, but the machine's precision depends on something less visible. Tolerance. Metal expands under heat. Shafts elongate. Bearings shift. Clearances that were exact at dawn begin to drift by midday. Engineers compensate, adjusting lubrication rates, tightening assemblies, recalibrating alignments. The machine is not static. It evolves throughout the day. Its behavior changing with temperature, load, and time. This is where human judgment becomes critical. Operators do not control the machine in the traditional sense. They interpret it, a subtle vibration through the platform, a change in the pitch of grinding stone, a delay between cycles that suggests resistance where there should be flow. Instruments provide data, but the machine communicates through sensation, through sound, through movement, through patterns that must be learned over years. Because when those patterns break, the consequences are immediate. A misaligned jaw does not simply reduce efficiency. It introduces uneven force, concentrating stress in areas not designed to bear it. A bearing running dry does not fail gradually. It overheats, seizes, transfers load to adjacent components that cascade into failure. And a pressure spike in the steam system does not warn twice. There is no margin for inattention. The machine is designed to operate at the threshold of its own limits. Every component is calculated to withstand expected forces with minimal excess. Redundancy is a luxury that scale does not permit. To build larger is to build closer to failure, and yet the system depends on continuity. Stopping the machine is not trivial. Cooling, depressurization, realignment, all require time. Time interrupts production. Production is obligation, so adjustments are made while it runs. Repairs are performed within reach of moving parts. Risks are accepted, normalized, integrated into routine. Because the machine does not pause for caution, it converts it into delay. And delay is something the system surrounding it cannot afford. Steel is strongest just before it fails. That is the deception at the center of every great machine. Under load, metal can appear calm. A beam holds, a shaft turns, a housing remains intact. To the eye, nothing changes. But deep within the structure, stress accumulates invisibly. Molecular, incremental, patient. Repeated force leaves a record too small for any operator to see. Heat alters hardness. Friction removes tolerance. Tiny imperfections, once irrelevant, become points of concentration where pressure gathers and waits. The crusher lived in that condition. Its scale made it formidable. It also made it vulnerable. 14,000 tons did not eliminate weakness. They distributed it across a larger body. Each day of operation introduced expansion and contraction through every major assembly. Morning cold tightened fittings. Afternoon heat loosened them. Bearings warmed, grease thinned, shafts lengthened by fractions that seemed trivial until they aligned with strain already present elsewhere. The machine endured by balance. If the feed was steady, the load remained predictable. If stone entered at the intended size and rate, force moved through the chamber as designed. But quarries do not produce perfect consistency. A slab cut too large, a fragment lodged at the wrong angle, a momentary surge in input, any of these could convert managed pressure into shock. The system absorbed what it could. Beyond that, it passed the burden inward. Sometimes the first warning came as sound, a metallic report sharper than the usual rhythm, a grinding note where motion should have been smooth. More often it came as heat. Operators touched housings with the backs of their hands, reading danger through instinct before instruments could confirm it. A bearing too hot to approach meant lubrication had failed or alignment was drifting. A hot bearing could become a seized bearing. A seized bearing could twist a shaft. A twisted shaft could tear the machine apart from within. Steam brought its own violence. The boilers that powered the crusher converted water into stored force under immense pressure, and pressure is indifferent to intention. Riveted seams, valve seats, pressure lines, every one of them depended on maintenance so exact that neglect could become explosive. A leak was never merely a leak. It was a sign that containment had weakened. Superheated steam escaping through a pinhole could cut flesh. A ruptured line could blind, scald, or kill in seconds. Yet production continued. Because the danger was familiar, it became ordinary. Men learned to work around heat, around noise, around the smell of oil beginning to burn. They learned the difference between tolerable risk and immediate threat, though even that distinction was often made too late. The machine taught them its limits, not through instruction, but through punishment. And steel, for all its strength, could not forgive repeated excess forever. Every additional ton demanded, every shortened maintenance interval, every decision to keep the crusher running through one more shift moved it closer to a threshold no ledger could measure exactly. The system appeared stable until the instant it was not. That was the true boundary of industrial power. Not whether a machine could be built large enough to dominate stone, but whether those who depended on it could recognize the moment when strength had already begun to turn into ruin. They arrived before the light, boots on gravel, breath visible in the cold, figures moving along paths worn into the quarry by repetition. There was no announcement of the shift beginning. The machine marked time more precisely than any clock. When it ran, work existed. When it stopped, something had gone wrong. The men did not gather at a single point. They dispersed, each to a station defined not by preference, but by necessity. Feed operators positioned themselves above the crushing chamber, guiding stone into the jaws with long bars, correcting jams before they became stoppages. Mechanics moved along the flanks of the machine, listening, inspecting, adjusting lubrication points that demanded constant attention. Boiler tenders remained near the source of power, managing heat and pressure with a vigilance that allowed no distraction. No role was separate. Every action affected the others. A delayed feed altered load. A fluctuation in steam pressure changed cycle timing. A missed warning in one area propagated into strain elsewhere. The system functioned because the men within it learned to anticipate consequences before they appeared. They worked in proximity to force, not abstract force, but immediate, physical, unforgiving. The jaws did not slow for error. The gears did not disengage for hesitation. There were no guards in the modern sense, no barriers sufficient to contain motion on this scale. Safety was procedural, enforced through habit and awareness rather than design. Injury was not exceptional. It was expected. Hands crushed between stone and steel, clothing caught and pulled into rotating shafts, burns from steam that escaped without warning, hearing diminished over years until the machine's constant thunder became a muted presence, replaced by vibration felt through bone. Each incident was recorded, noted, absorbed into the collective understanding of risk, and still they remained, because the machine provided what little else could. Wages tied directly to output, longer shifts when demand increased. Overtime that compensated for the danger in ways that few alternatives could match. In towns built around quarries, employment was not optional. It was the condition of survival. Families depended on the continuity of operation as much as the machine itself, so the men adapted. They learned to read one another without words, gestures replacing speech in an environment where sound could not carry meaning. A raised hand signaled delay. A sharp motion indicated danger. Eye contact confirmed understanding. Communication became efficient, stripped of anything unnecessary. They also learned the machine's moods. There were days when it ran smoothly, each cycle predictable, each output consistent. On those days, tension eased slightly, not removed but reduced to a manageable level. Then there were days when irregularities accumulated. Feed became inconsistent, heat built faster than expected, vibrations shifted, subtle but persistent. On those days, every man remained alert, waiting for the moment when deviation would become failure. Breaks were brief, meals taken quickly, often in proximity to the machine, because distance meant losing awareness. Fatigue accumulated across shifts that blurred into one another, sleep reduced to intervals dictated by production schedules rather than human need. The body adjusted as best it could. When it failed, another man took the position. Because the machine did not recognize exhaustion, it required continuity, and continuity required bodies willing to occupy the space around it, to endure its demands, to accept its risks as conditions that could not be negotiated. In return, it offered stability of a certain kind, predictable wages, consistent work, a place within a system larger than any individual could influence. For many, that was sufficient. For others, it was a compromise made daily, weighed against the knowledge that each shift carried the possibility of not ending as expected, and always, above them, within them, around them, the machine continued its rhythm. Crush, release, crush again. Until something broke that could not be repaired in motion, the change did not announce itself. It entered the rhythm as a discrepancy so small it could be dismissed. One cycle fractionally delayed, one vibration slightly out of sequence. The machine continued to operate. Stone fed into the chamber. Output flowed. Nothing stopped. But something had shifted. A slab entered at the wrong angle. Too large, too irregular. Its weight distributed unevenly across the jaws. Instead of descending smoothly, it caught. Compression increased. The flywheels carried momentum forward, forcing the motion to continue even as resistance rose beyond expected limits. Stress traveled through the system, searching for release. It found none. The next cycle struck with greater force. Oh, the stone did not fracture cleanly. It splintered, fragments lodging where clearance was minimal. The mobile jaw hesitated, then forced its way through, grinding against obstruction. A sound cut through the noise, a sharp metallic crack that did not belong to stone. Several men turned at once. They did not speak. They listened. The vibration changed, not in magnitude, but in pattern. A tremor moved through the platform, irregular, pulsing where it should have been constant. One operator signaled to reduce feed. Another moved toward the bearing housing, already sensing heat rising beyond tolerance. The machine continued to run, its motion now carrying an undercurrent of instability. Then the pressure surged. In the boiler house, a valve struggled to compensate for fluctuating load. Steam flow increased to maintain cycle timing, pushing the system toward limits set long before the machine began operating at its current demand. Gauges climbed. A needle approached a mark it was not meant to reach. Back at the crusher, the obstruction worsened. Fragments compacted into a mass that resisted compression, forcing the jaws into misalignment. Metal met resistance it had not been designed to sustain repeatedly. Stress concentrated along a single axis, focusing force into a point where material fatigue had already begun its quiet work. The bearing failed first. It did not explode. It seized. Rotation halted on one side while momentum continued on the other. The shaft twisted, imperceptibly at first, then with a violence that translated through the entire frame. A second crack followed, louder, deeper, the sound of steel exceeding its limits. Men moved to disengage power. But the machine did not stop instantly. Stored energy remained. Flywheels continued their rotation, carrying force forward even as control was lost. The jaws closed one final time under uneven load. The misaligned assembly could not distribute the pressure. Something gave. The fracture tore through the housing. A section of steel split, releasing tension in a single catastrophic motion. Fragments of metal, sharp, heavy, accelerated by forces beyond control, were expelled outward. The ground shook as components shifted out of alignment, tearing at connections designed for precision, not collapse. Steam followed. A ruptured line released pressure into open air, expanding instantly, obscuring vision, carrying heat that burned without flame. The noise overwhelmed everything, a sustained roar that erased distinction between machine and environment. Then, as suddenly as it began, motion ceased. Silence did not return immediately. It emerged slowly, as residual sounds faded. The hiss of escaping steam, the settling of displaced material, the distant echo of impact dissipating across the quarry walls. Where the machine had stood in perfect alignment, there was now distortion. Bent frames, misplaced components, a system designed for continuity forced into stillness by failure that could not be contained. Men moved cautiously, not toward the machine's center, but around its edges, assessing, searching, counting. Some called out, others did not. The air carried the weight of what had occurred, not as spectacle but as interruption. The rhythm had broken, and with it, the assumption that it could not. The stoppage reached beyond the quarry before the dust had settled. A machine of that scale was never an isolated instrument. It was a dependency embedded within contracts, transport schedules, payroll systems, and construction timetables stretching far beyond the pit itself. When it failed, the consequences moved outward in concentric circles. Rail sidings filled first. Wagons scheduled to receive graded aggregate stood idle, their departure times slipping by the hour. Dispatchers sent inquiries. Yardmasters revised manifests. A delay of 1 day could be absorbed. Longer than that, and the absence of stone began to alter work hundreds of miles away. Track crews waiting on ballast could not secure new line. Bridge projects dependent on crushed fill slowed or stopped. Municipal roadworks, already operating within narrow seasonal windows, lost momentum they might not recover before weather turned. The quarry town felt the shock differently. For the laborers, stoppage meant uncertainty. Wages tied to output vanished the moment the machine fell silent. Men injured in the failure required treatment that families could scarcely afford. Those unhurt faced a harsher calculation: whether repair would be quick enough to preserve employment, or whether the shutdown would spread into layoffs, reduced shifts, unpaid waiting. In industrial settlements built around a single operation, interruption was never merely technical. It became domestic. Kitchen tables absorbed what the machine could no longer carry. Ownership saw the breakdown in another language: insurance claims, replacement lead times, contract penalties, and lost tonnage per day. Engineers were summoned not simply to understand what had happened, but to determine how rapidly production could resume. There would be investigations, yes, but not all investigations sought the same truth. Some looked for mechanical cause, others looked for liability. Most looked for the shortest path back to output, and the men who had worked beside the crusher understood something the ledgers did not. The failure had exposed the system itself. It showed how tightly ambition had been wound around a single machine, how little slack existed between normal operation and cascading disruption. The giant had been praised for its capacity, its efficiency, its ability to turn hillsides into infrastructure at industrial speed. Now, the same scale revealed a corresponding fragility. When too much depends on uninterrupted force, one fracture becomes many. Repairs would come. They always did. Steel could be recast, bearings replaced, housings reinforced, procedures rewritten. But the silence after the failure lingered as evidence that progress built on compression carries its own hidden recoil. The machine had broken stone for years. In one violent interruption, it broke schedules, wages, assumptions, and the illusion that industrial control was ever complete. They did not rebuild it as it was. They could not. The failure had rewritten the limits of what the machine was allowed to be, even if no one would admit it in those terms. Official reports spoke in precise language: load irregularities, bearing degradation, thermal expansion exceeding tolerance. Recommendations followed: reinforce the housing, increase lubrication flow, widen clearances at critical points, recalibrate feed protocols. Each adjustment addressed a symptom. Together, they formed something larger: a recognition that scale had consequences that could no longer be ignored. The reconstruction began with steel. Sections were recast with greater mass. Their thickness increased not to improve performance, but to delay failure. Additional bracing was introduced, redistributing stress across wider surfaces. Where force had once concentrated, it was now diffused, never eliminated, only spread thin enough to be endured longer. Engineers modified alignments, accepting slight inefficiencies in exchange for stability. Precision was traded for resilience. Power systems were altered as well. Valves were redesigned to respond more gradually, smoothing fluctuations that had once been transmitted directly into motion. Pressure limits were adjusted downward, marginally but enough to reduce peak stress during irregular cycles. Or the machine would produce slightly less per hour. Over time, it was expected to produce more by surviving longer. Procedures changed. Feed operators were instructed to reject oversized stone rather than force it through. Maintenance intervals were shortened, even when the machine appeared to be running smoothly. Inspections became more frequent, more formalized, documented in logs that attempted to convert intuition into record. The goal was not to eliminate risk, that was impossible, but to recognize it earlier, to intervene before it aligned into failure. And still, the demands did not recede. Railways continued to expand. Cities continued to rise. Contracts continued to specify tonnage that pressed against the revised limits of the rebuilt machine. Efficiency, even reduced, remained essential. There was no alternative system waiting in reserve. The crusher, reinforced and recalibrated, returned to operation because it had to. Men returned with it. Some replaced those who had not. Others resumed positions they knew too well, now carrying memory of the failure as part of their work. The machine's rhythm began again, slightly altered, subtly different, but familiar enough to re-establish routine. Crush, release, crush again. The changes held. For a time, output stabilized, failures diminished. The system appeared to have adapted, its vulnerabilities addressed through engineering and procedure. Reports reflected improvement. Confidence returned, not completely but sufficiently to allow the cycle to continue. Because the lesson had not been to reduce ambition, it had been to manage its consequences, and management. And in an industrial system rarely means retreat. It means adjustment. The machine endured longer. It operated within revised boundaries. It met demands that continued to grow, even as those boundaries were approached once more. The balance between force and failure had shifted, but it had not disappeared. It had only been postponed. The machine did not remain alone for long. Its design, refined through failure, reinforced through necessity, became a template. Other quarries adopted its principles, scaled them to their own demands, integrated them into expanding networks of extraction and production. What had once been a singular achievement became a standard. Crushing capacity increased across regions, then across nations, until the reduction of stone at industrial scale was no longer remarkable. It was expected. With that expectation came transformation. Railways extended into territories previously considered inaccessible, supported by a continuous supply of precisely graded aggregate. Roads evolved from temporary routes into permanent systems, layered and compacted to endure increasing weight and traffic. Cities grew upward and outward, their foundations, composed of material processed by machines, descended from the original giant. Bridges spanned distances once deemed impractical. Ports deepened. Infrastructure multiplied. The landscape itself changed. Hills receded. Valleys widened. Entire sections of terrain were redefined, not by erosion over time, but by deliberate removal. What had taken geological ages to form was dismantled within decades, its substance redistributed into the frameworks of human expansion. The absence of stone in one place became the presence of structure in another, and beneath it all, the same principle persisted. Destruction as a prerequisite for construction. The crusher did not invent this relationship, but it amplified it to a scale that altered perception. It demonstrated that natural limits could be negotiated through engineering, that resistance could be converted into resource, that permanence was conditional when confronted with sufficient force applied consistently. But the legacy was not only physical, it was systemic. Industrial processes built around continuous operation, optimized output, and managed risk became models for other sectors. The logic of the crusher, feed, compress, produce, repeat, translated into factories, into supply chains, into economies structured around throughput and efficiency. And the machine's rhythm extended beyond stone. It entered time itself, And yet, its history remained embedded in every structure it made possible. Each railway line carried the memory of quarries that fed it. Each city foundation rested on material that had once resisted reduction. The visible achievements of expansion concealed the invisible record of what had been broken to create them. The crusher's legacy was not a monument. It was a method. The machine still runs. Not in its original form, not in the same quarry, not with the same men, but in principle unchanged. The logic endures wherever material is forced to yield faster than time would allow. We have refined it, scaled it, hidden it behind cleaner systems and quieter processes, but the exchange remains. We break in order to build, and somewhere, always, there is a point where pressure accumulates beyond what can be seen, waiting, as it always has, for the moment when strength becomes failure.